All right, so if we take a look at 21, 21 said, I have 5 times 10 to the 6th times 6 times 10 to the 2nd. Is this the one that you're talking about? All right, so the first thing I'm going to do, since this is multiplication, I'm going to move the numbers next to each other that I can actually multiply and still leave this in scientific notation. So I have my 6 and my 5 that we can multiply together, and I have my powers of 10 that I can multiply together. So I'm going to have 5 times 6 times 10 to the 6th times 10 to the second. Are you cool with that? Okay. 5 times 6 is 30. Times 10 to the 6 plus 2. God bless you. God bless you. So this is 30 times 10 to the 8th. Michaela, are you cool so far? Okay. That 30 is not in proper form. So I'm going to go ahead and change that so that we have to move our decimal one place to the left. So I made that number, that standard form number, it was big. So I have to have my power on my exponent, my 10, be a positive power. So it's 3.1 times 10 to the 1st times 10 to the 8th. You guys work up on your desk. I'm not in your living room. Work up on your desk. All right, so now I have 3.0, or simply 3, times 10 to the 1 plus 8, which is 3 times 10 to the 9th. Does that help you? Awesome. Christiana, what did you want me to do? 23? Excellent. All right, so I take a look at 23. 23 said I have 9 times 10 to the negative 3rd times 7 times 10 to the 8th power. Is this the one you're talking about, sweetie? All right, so can I give you guys all a piece of advice? You guys, everyone look over here at me. This is my piece of advice. When you're doing your homework, I have you guys go down your page, correct? Okay. Which leaves sometimes an obnoxious amount of extra room on the side of your page. How many of you guys notice that? Okay. That's where you put your corrections. So you need to have room in your homework to make corrections next to the problems should you need to do corrections or notes or anything. All right? What I recommend you don't do, I recommend that you don't do this. Here's the original problem, and I'm going over here to put the new one, where we're flipping back and forth between the old and the new. Or you're not flipping back and forth, you're just putting the corrected material here. Why do you think I want you putting it next to the original? Why do you think there's an importance to putting it next to the original? Alex? So you don't make a mistake when you're carrying it over. I totally agree with that. Why else? Jack? Yes. So you can compare the two. How many of you guys have heard me say in class, I'm so glad you made that mistake? Why do you think I'm telling you that? Why do you think I celebrate people making mistakes in my class? Frankie?
So you can show them how to do it because everyone else might make that mistake.
Exactly. Right? Knowing what the mistakes that you made are is going to help you learn how to do it right. If you're not seeing what you did wrong when you're doing it the right way, you may still make the same mistake. Does that make sense to you guys? All right, so anytime, even when I'm coaching, if I see someone doing something wrong, I have them do it for me wrong again, so they can feel what that is. All right, and then I have them do it right so they can feel what that is, and they can physically feel the difference between I'm a volleyball girl. So difference between holding your hands properly and not, in setting properly or not.
To the office, please. Maya Clinton, Alex Aiden, and Austin Madany. Also, this is your last call. If any classroom has forgotten harvest money, please send a student with it down to the office. Thank you.
All right, so I want you guys, it's the same thing. I want you guys seeing the mistake and seeing the correct work. All corrections need to go next to your work. Do you guys understand? Okay. So, this is the problem that we have. So I'm going to move my 9 and my 7 next to each other. And then I'm going to move next to each other times 10 to the 3rd times 10 to the 8th. Please make sure your multiplication between your the 10 part of your scientific notation is an x. All right, Christiana, what's 9 times 7? So I have 63 times 10 to the, well, I'm adding my exponents because I'm multiplying two numbers with the same base, so I have negative 3 plus 8. So I have 63 times 10 to the 5th power. So are you cool with that? Okay. So now I need to change that 63 into proper scientific notation. So I'm taking a bigger number and I'm making it into scientific notation. So I move my decimal one place to the left. So I have 6.3 times 10 to the positive first because my power on my 10 or my standard form was big. And then I'm putting that back together with the original scientific notation. So now I have 6.3 times 10 to the 1 plus 5, which is 6.3 times 10 to the 6th. So you guys, even if you got that right, I want you all looking to see if you have the right work. Everybody. This is number 23. Even if you got it right, you're looking to see, did I show the right work? And all of the steps in the right work. That's everything that I should see. Frankie, we're not doodling, you're doing what I'm telling you to do. You're looking at the work, you're looking to see, not did I get the right answer, did I show all my steps right? All right, are there any other questions? Okay, so what I would like for you guys to do is you may start working on your chapter review for the remainder of the class.